For decades, fixing your own appliances, tools, and machines wasn't just possible, it was normal. If something broke, you didn't replace it. You repaired it. You could walk into a local parts store, find exactly what you needed, and get your machine running again the same day. But that reality is disappearing. Today, more and more people are discovering something frustrating. The part they need either doesn't exist, is impossible to find, or costs so much that repairing the product no longer makes sense. So what changed? Why are parts disappearing? And more importantly, why does it feel like fixing your own equipment is becoming impossible? To understand this shift, you have to look at how products used to be designed. Older machines were built with repair in mind. Components were modular. Parts could be removed, replaced, and serviced independently. Manufacturers provided diagrams, part numbers, and access to replacements. A washing machine motor could be swapped. A refrigerator thermostat could be replaced. A power tool switch could be repaired. These systems weren't just functional, they were serviceable. Now compare that to many modern products. Instead of modular components, you'll often find integrated assemblies. Instead of replacing a small part, you're forced to replace an entire unit. A failed bearing might be built into a sealed drum assembly. A faulty button might require replacing a full electronic control panel. A small sensor failure could mean swapping out an entire board. This isn't accidental. It's a result of design decisions driven by manufacturing efficiency and cost control. Fewer individual parts mean faster assembly and lower production costs. But it also means less repairability. The second major shift is the rise of electronics. Mechanical systems are being replaced with electronic controls. What used to be a simple switch or timer is now a circuit board. And while electronics offer precision and features, they introduce a new problem. They are far less accessible to repair. A mechanical component can often be diagnosed visually or tested with basic tools. An electronic board requires specialized knowledge, equipment, and sometimes proprietary diagnostics. And even when the issue is identified, the solution is rarely component-level repair. Instead, manufacturers sell the entire board as a replacement. This brings us to another critical issue: part availability. Manufacturers today control the distribution of parts much more tightly than they used to. In many cases, parts are only available through authorized service channels. Independent repair shops and individual consumers face limited access or higher prices. And sometimes, parts are discontinued entirely after a relatively short period. This creates a situation where a product may still be physically functional, but effectively unrepairable. Another factor is supply chain optimization. Modern manufacturing operates on just-in-time inventory systems. Parts are produced in quantities that match projected demand, not long-term service needs. Once production stops, restocking those parts becomes unlikely. This is especially true for lower-cost consumer products. From a business perspective, maintaining long-term parts inventory is expensive. From a consumer perspective, it means fewer repair options over time. There's also the issue of proprietary design. Many modern products use custom components that are not interchangeable with generic alternatives. Connectors, housings, firmware, and even physical dimensions are often unique to a specific model. This prevents third-party manufacturers from easily producing compatible parts. It also locks consumers into the original manufacturer's ecosystem. If they stop supporting the product, repair becomes significantly harder. Another major change is the economics of repair itself. Labor costs have increased. Time required for diagnosis has increased, especially with electronic systems. And parts, when available, can be expensive. At a certain point, the cost of repair approaches or exceeds the cost of replacement. This shifts consumer behavior. Instead of fixing products, people replace them. And as that behavior becomes more common, manufacturers have less incentive to prioritize repairability. This creates a feedback loop. Less repairability leads to more replacement. More replacement reduces demand for parts. Reduced demand leads to fewer parts being produced. Over time, DIY repair becomes less viable. There's also a knowledge gap developing. Previous generations often had hands-on experience with mechanical systems. They understood how things worked and how to fix them. Modern products are more complex, and fewer people are exposed to repair skills early on. At the same time, access to repair information is not always guaranteed. Some manufacturers restrict service manuals, diagnostic tools, or software access. Without that information, even skilled individuals face limitations. It's not just about having the right tools, it's about having the right data. Another overlooked factor is product lifecycle strategy. Many companies design products with a defined life cycle in mind. Not necessarily planned obsolescence in a direct sense, but a realistic expectation of how long the product will be supported. Once that window passes, parts availability and support naturally decline. This is especially common in electronics-heavy products. Software support ends. Parts become scarce. Repair becomes impractical, and the product is effectively phased out. It's also worth noting that this trend isn't uniform across all industries. Some sectors still prioritize repairability. Commercial equipment, industrial machinery, and professional-grade tools are often designed for long-term service. Parts remain available. Documentation is accessible. Systems are modular. Why? Because downtime in those environments is costly. Repair is not optional, it's necessary. But in consumer markets, the equation is different. Convenience, price, and feature sets often take priority over long-term serviceability. And that shift has fundamentally changed how products are built. So where does that leave DIY? It's not completely dead, but it is changing. DIY repair today often requires more than basic tools. It requires research, access to parts networks, and sometimes specialized knowledge. Communities, forums, and independent repair advocates are filling some of the gaps. There is also growing awareness around right-to-repair initiatives, efforts aimed at improving access to parts, tools, and information. These movements highlight the demand for repairability. But the reality is this: the environment that made DIY repair easy and accessible in the past no longer exists in the same way. Products are different. Supply chains are different. Business models are different. And all of those changes contribute to the same outcome. Parts are disappearing. Not always literally, but functionally. They're harder to find, more expensive to obtain, and often replaced by entire assemblies rather than individual components. So when your appliance fails and you can't find the part you need, it's not just bad luck. It's the result of a larger shift in how products are designed, manufactured, and supported. And until those underlying systems change, DIY, as it once existed, will continue to fade.